Okay, let's take a look at dilations. So, dilations are either enlargements or reductions. We're either making our shape bigger or we can make our shape smaller. And a bigger, that would mean the scale factor k is greater than 1, and if we reduce it or make it smaller, then the k is going to be less than 1. The scale factor, which is what this k is the ratio of corresponding side lengths. So let's just start with a kind of a triangle here. Let's make this a 3 by 4 triangle. Okay, so that's 3. That distance is, that side length is 4. And then the hypotenuse would be 5. And then a right triangle. Okay, and so if I talk about I want to dilate this, I have to really tell you two things. Since it's in a coordinate grid. If it wasn't in a coordinate grid, I just need to know the scale factor. Okay, so let's say that the scale factor is 2. The scale factor is the ratio of the corresponding side lengths. So what are the new side lengths? Well, instead of being 3, the triangle is going to be 6 by 8, and it'll make the hypotenuse 10. Right? If I dilate something again, I'm creating a similar figure. And in this case, all the side lengths are just twice as big. The angles will be the same. It'll basically be the same shape, meaning it'll be a triangle, except all the side lengths will be twice as big. But if it's in a coordinate grid, I actually have to know where the dilation is centered. In this particular example, let's put the center at 0, 0. That's kind of where the dilation starts. Or we can think of that point is the only point in the grid that doesn't actually change. Everything from it expands by 2. Okay? So this, in this case, is my center of my dilation. And all you really have to do is figure out one coordinate where it goes, and then all the other coordinates will make sense. Okay, so for this example, I'm going to have to write in some coordinates. Let's say that's at 2, 1. That would make this particular point, considering it's 3 up. So same x value, 3 up would be 2, 4. And this one is have the length of 4, so same x value, same y value, and 4 over from 2 would be 6. That'd be 6, 1. Okay, everyone okay that it's in a coordinate grid now? This is certainly the y-axis and the x-axis. Okay, so if I'm going to enlarge this by 2, all the side lengths are going to grow, and the distance each of the coordinates are from the center will grow by 2. And hopefully it makes sense that I'm going to move these coordinates double away from the center of this dilation, and that will also increase the side lengths by a factor of 2. And I'll show you what I mean. Okay. So this point, this corner of the triangle is 2, 1. And since the center is at 0, that means it's 2 over and 1 up. If I want to double that length, I just need to put that coordinate at 4 over and 2 up. Okay, so I'm going to take this and I'm going to put it at 4, 2, which is probably something like right here. That's the coordinate of that triangle. Okay, now I'm going to double this coordinate point because it's 2 over and 4 up. So let's make it 4 over and 8 up. And so now it's going to be something like this. Okay, this is at 6, 1. I'm going to make it at 12, 2. So it's probably like over here almost into my words. And my new triangle. And what I know is that not only are all of the coordinates double away from the center, but I also know that all the side lengths were doubled. If you remember, I can maybe write in these new coordinates in blue. This coordinate used to be 2, 4, and now it's 4, 8. This coordinate was 2, 1. Now this coordinate is 4, 2. This coordinate was 6, 1, and I doubled it to make it 12, 2. And now we can look at the side lengths. Look, 4, 2, 12, 2, that distance is 8. That distance is 8. Look, I doubled it. It used to be 4, and now it's 8. This distance is 4, 2 to 4, 8. That's 6. Look, it doubled. And I know a 6, 8 triangle has a 10 hypotenuse. and also I doubled the 5 hypotenuse. Again, if you just told me that the scale factor was 2, I know for sure that the next shape instead of 3, 4, 5 is 6, 8, 10. That's the easy version. If it's on a coordinate grid, then I have to talk about the center and I have to dilate it from some fixed point. The center is fixed. It didn't move. 0, 0 stayed at 0, 0. And then all I have to do is double the distance. Everything is from that point. And really, I just had to do 1 point. If all you did was 2, 1 and you put it there, then you knew that it was 6, 8, 10, and you could have found the other coordinates that way. Okay, I actually did each coordinate separately and just to show you that it still made it 6, 8, 10, but I didn't have to. On this next example, I'll take something and I'll make it so it's not centered. It's not centered at 0, 0. We can center it somewhere else. Let's take a rectangle here. And let's put a rectangle at 3, 2. Make this whatever we want. Okay, let's make that point at 3, 2. And we'll make this 3 long. So if it's 3 long, then this is going to be 6, 2. And we'll make it 5 high. So that's 3, 7. 5 high is 6, 7. Okay, I got my coordinates, and I'll go ahead and label everything in blue. So this side length is 5, and this side length we said was 3. Okay, let's have a scale factor of 3. So I'm going to enlarge this thing. I'm going to make all the sides 3 times bigger, but I'm going to center it at 3, 2. So I'm actually going to put the center on the corner of the rectangle. Again, if it's not on a coordinate grid, these problems are super easy. A scale factor of 3 means the ratio of the corresponding side lengths is 3 to 1. So the new shape's going to have, instead of 5, it's going to be 15, and instead of 3, it's going to be 9. All the side lengths are 3 times bigger, okay? But if it's centered here, I need to increase the distance, each coordinate point, by 3 times from this being my center. The cool part is, if this is the center, that point is fixed. It doesn't even have to move. And all I gotta do is move all the other ones 3 times as far as they are away from this. But this is easy. Look, this coordinate is just 3 away from this center. So now it's going to be 9 away from this center. So all you gotta do is draw that and make it 9 long. This is 5 away. All you gotta do is move this point so it's 3 times as far from this point. So make it 15, and then you can connect the dots. There's my new rectangle. We can find the points. This whole distance is 9. So go 9 over from this guy. 3, 2, 9 over would make that 12, 2. This distance was 5. Now the new distance, the new big rectangles, is 15. So stay at that x value and go 15 up. You'd be at 3, 17. And then you can figure out this one either from going from there or there, because you know this distance is 9 and you know that distance is 15. Let's just do this one, 12, 17. Hopefully you can see that these two share x values and these two share y values. These share x values. And then our big new triangle is this full red one. Okay, there's our new one, where the original one was right here. The fixed center didn't move. We're over here, we had this guy, and then we blew it up from there, and in this case, we made all the side lengths twice as big. Over here, we made them 3 times as big. Okay, and we centered it on the shape. So let's do another one, and this time, we will make the center not the origin, and we won't put it actually on the shape itself. We'll put it off the shape, and we can see kind of what happens. Okay, let's make this one a real skinny triangle. How about, you know what? How about we put it over here? Who cares where we put it, right? Let's put it in this quadrant. How about that? Let's put this at, it looks like, what, 1, -4. And let's make that 2 over. So that's at 3, -4. Let's make, so that distance is 2. Let's make it 6 down. 6 down from there. So 1 and then 1, -10, and then 6 down from there would be 3, -10. Okay, so we have our new rectangle, and it's 2 by 6. Okay, let's put the center somewhere else. We can put the center wherever we want, and we can make the scale factor whatever we want. Let's make the scale factor 4. Okay, so I already know what the new shape looks like. For sure, all the side lengths are 4 times bigger. So instead of being a rectangle that's 2 by 6, it's going to be a rectangle that's 8 by 24. For sure, that alone tells me everything. Since it's on a coordinate grid, I can pick a center to expand from. Okay, so we'll pick a crazy one. Let's put our center, let me think. This is, we'll go -2, and we'll go down here to, I don't know, how about like something like there. -2, -6. Something crazy right there. All right. Now, all we're going to have to do, remember, is move 1 point. We can move all 4, but all you really have to do is move 1 point. Find the distance this point is from that corner, and then quadruple everything. Okay, so let's figure out this. How far is this away? Like that distance. So let's figure out how far over it is, and then how far up it is. Okay, so -2 to 1, how far is that over? Well, that's 3 over. And how far up is it? What's that, -6? And it goes to -4, so it's 2. Everyone okay with this? This coordinate point right here, this big blue one, is 3 horizontally and 2 vertically away from my center, right? The center here that we picked is -2, -6. And I need to quadruple everything. So instead of being 3 away and 2 up, I need to go 12 away and 8 up from this point. So 12 to the right puts me at 10. So I'll write that down. So I want to take this, and then I want to go 12 this way and up 8 from my center. That's where I'm moving this point to. It was 3, 2, and now let's go 12, 8. So start here and go 12. You're going to be at 10. You're going to be at 10, 2. So move it right about there. Okay, that's the point, 10, 2. From this center, I moved that point instead of 3, 2. It is now 12 away and 8 up. So I've quadrupled everything. And look, all I have to do now is quadruple all the side lengths. 10, 2, go 8 this way. And go, quadrupling that is 24 down. So 24 down is way down there. Okay, and I'm exactly then. This is 24. And because that's quadrupling that, and then quadrupling 2 makes that 8. So it's 8 by 24 instead of 2 by 6. I moved it from the center. Let's check all the other coordinate points. Okay, let's see how this would work. Make sure we're thinking straight. Well, let's check this one. This is at 10, 2. If I go down 24 from that, I'm going to be at 10, -22. Okay, these 2 points are corresponding. Okay, let's figure out how far is this one away from my center, just to make sure that all this worked. So let's go down and over. How far did I do that? -2 over to 1 should have been a move of 3. -6 to -10 was down 4. Okay? So this coordinate point was down 4 over 3. And I'm claiming that this point better than be down 16 over 12. Okay, think this through again. Instead of going down 4 over 3, I need to go down 16 and over 12. If I quadruple these distances, I will quadruple the distance that point moves from the center. Okay, so go down, or excuse me, go over 12 from -2, boom, you're at 10. Go down 16 from -6, boom, -22. Meaning this distance and that distance is exactly a ratio of 4 to 1. This new triangle is exactly where I'm supposed to be. And again, if you wanted to find all these things, other points, those are easy because you know that distance is 8. So just move 8 more over and get 18, comma 2. Move 8 over from this one and you're going to be at 18, comma -22. And you can check all these coordinate points. These 4 points all moved here and here and here. All of their distances from the center moved by a factor of 4. All the side lengths got bigger by a factor of 4. Okay, so there's my original shape. And there's my final shape. If you do enough practice, these will all start to make more sense. Okay, I'm going to do, let's look at something really quick. This is a property that I want to look at. Okay, look at my triangles. So my triangle 1 in my first example. Okay, what's the original perimeter? The perimeter of the first object. The perimeter of the first object is 3 by 4 by 5. That would make 12. Okay, and then what's the perimeter of the red, the new shape? The perimeter of the red is 6, 8, and 10. That's 24. You're like, oh, look at that. All the sides were doubled, and the perimeter was doubled. Cool, check that out. What do you think happened to the area? What's the original area? Well, this is a triangle, so 1/2 base times height. 1/2 base times height gives the area to be 6. And then what's the area of the enlarged figure? 1/2 base times height would make that 24. And you're like, oh, check that out. The perimeter doubled, like the scale factor. The area quadrupled, which ends up being the scale factor squared. Think that through. You multiplied the base and the height by a factor of 2, and then you multiplied them together to find an area. So really, you multiplied the area by 2 factors of the scale factor. And so the area ratio will be the scale factor squared, okay? Let's look at this one, right? The first triangle, or the first rectangle. We went from here, and then we got that bigger one. So what's the first perimeter? Remember, the first one was 3 by 5, so that's 3, 5, 3, 5. So that's 16. And then what's the perimeter of the red? Oops, P2. The perimeter of the red, remember, we made it 3 times as big. So this was 15 over here, and this was 9. So 15 and 9 make 24. 24 and another 24 make 48. And look, the perimeter is 3 times bigger because the side lengths were 3 times bigger, and the perimeter is just adding up all the side lengths. So you make all the side lengths 3 times bigger, you're going to make the perimeter 3 times bigger. Let's look at the area. The original area is 3 by 5, so that's 15. And then the second area is 9 times 15. 9 times 15 is 135. And you're like, wait a second. And it should make sense when you start thinking, if I multiply this number by 3 and this number by 3, and I multiply them together to get the area, then the area should be 9 times bigger. 9 times 15 is 135. Again, the area ratio is the square of the scale factor. We could do the last one, the skinny rectangle one we did. The original perimeter, 2, 6, 2, 6, so that's 16. The second perimeter with a scale factor of 4 was 8 by 24. 8 and 24 is 32, so all the way around should then be 64. And you're like, oh, look, the perimeter's 4 times as much. It's the exact same as the scale factor. What's the original area? The original area was 2 by 6. That's 12 square units. And then the other one is 8 times 24. Ooh, 8 times 24. Can I do that in my head? That's 160 and 132, 192. I sure hope I did that right. And one of the things you want to know is, look, this was multiplied by 4. This was multiplied by 4. So the area got 16 times bigger. 16 times bigger. Look, 16 times bigger the area, 4 times bigger the perimeter because all the side lengths got 4 times bigger. This one's probably the easiest one to show that the perimeter is up by a factor of 3, but the area went up by 9 because you literally can put in 9 of that exact same rectangles, because what did you do to the rectangle? 3 times as wide, 3 times as tall, and so you have 9 times the area, which is the scale factor squared. Okay? I'm probably going to do one more smaller video on dilations and show a couple reductions, and maybe even put one where the dilation starts inside somewhere on the figure. But I know this was a little long, but this kind of went through all the coordinate stuff. If it's not on a coordinate grid, then it's way, way faster, because all you got to do, if K is 2, double the side lengths. If K is 3, triple the side lengths. If K is 4, quadruple the side lengths, and it's very easy to get similar figures. If it's on a coordinate grid, then it gets a little more confusing. Okay, hopefully this helps.